They changed locations, right?
Yeah. They're over by like Grizzly Police or something.
Okay, here we go. Logarithmic functions. So logarithmic functions. No.
Oh, I saw it coming in the homework yesterday. I was like, oh, this is too close to logarithms.
Yes. Logarithmic functions, just think exponential functions. And then you can also think exponential, and in that you can think essentially it's the inverse of an exponential function. Yes. Is what logarithms are. So it's just a notation that helps us work with, and there's some rules with logarithms that we can do, which also tie into the rules of exponents and bases. So if you have log base 10 of 5 to the, log base 10 of 100. So log base 10 of 100 is equal to 2. So that if we want to rewrite that in exponent form, that in exponent form is going to be 10 squared equals 100. So also with this, we typically would never write log base 10. Log base 10, we actually just write as log 100. And that's called our, anybody remember what we call that when it's a base 10? It's called our common log. Common log. Okay, so then our common log is base 10. And so you just write that as log 100 because it's common. Because we work in a base 10 system. Now, so then you can have other bases though. So if you said log base 3 of 81, okay, log base 3 of 81 would be equal to 4, right? Because you're saying 3 to the 4th power is equal to 81. So this is the same thing as stating 3 to the 4th is equal to 81. Now, and then if we had one with a variable, log base x of, doesn't matter, you could have 11.2, there is fine, is equal to, again, it doesn't matter over here because we have a variable going. So if I said write this in exponent form, the exponential form, we would just say base, right? Log base x, so you say x to the 9th is equal to 11.2. Which you could find, how do you find x there?
9th root.
Yeah, 9th root, right? Or take it to the 1/9. So yeah, 9th root, take it to the 1/9. There you go. Okay, so that's the basics of the logarithms, common log. Then, I think, Cole, you mentioned natural log. Yes. So natural log is just where it's a base of. So, by the way, remember, common log has a base of 10. It's called the common log. The natural log,
Base of e.
yeah, the natural log is going to be a base of e. So log base e of, we could do something like e to the 5th is equal to 5. So when you have log base e though, we don't write it as log base e. What do we write it as? ln of e. So ln of e to the 5th would be equal to 5. So ln log natural, and you have that button on your calculator as well. You have the log button on your calculator. Now most calculators nowadays allow you to do whatever base you want. The original calculators that we have just only have a base of 10, and then you would utilize books or tables to find what other log bases would be, and or even without a calculator, you have tables. Like I think this book probably has tables where you could have log base 10, and then you would have a whole host of values that you could use by looking them up in charts, pre-calculators. Okay, so natural log base of e, we don't write it as log base e, we write ln. Common log case of 10, we don't write it as that, we write it as log. There you go. So, there's, the idea is in some of these, the ones that they give you initially, or it would all be like in this section, would all be non-calculator usage. So, just for examples, you know, whatever we can call this number 1, but we said log base 2 of 64, and the idea is that this is going to be without a calculator, because a base of 2 raised to some exponent equals 64. Now when you go to solve these, you can either mentally do it like 2 to the what power, right, is equal to 64. Sometimes it's helpful for people to take that and then write it out like this. Log base 2 of 64 is equal to x, just to give it like a variable and think through the equation. The equation is 2 to the x is equal to 64. And so some people like that, and then they think through, okay, 2 to the 6th power, right? So 2 to the 6th power. So in other words, you write x equals 6. Technically, it's like, well, there was no x involved in the original, but I'm not going to mark you wrong. You know, you say, okay, x is equal to 6. Technically, the answer is just 6, because again, there's no variable here. That's okay. But put it as equal to x, it makes it easier sometimes to look at. So all these that they give you are going to be no calculator needed. So if you have log base 5 of 1, we'll call this number 2 here, 0. You bet. Why 0?
Because 5 is 0.
Yeah, 5 to 0 is equal to 1. That one's kind of unique because it's like you don't see 1 as a power of 5. They're not going to give you these non-calculator one, right? You don't need to write this, but they're not going to give you log base 6 of 15.9 without a calculator, right? Because you'd be saying 6 to the what gives me 15.9. And you're like, I don't know. Yes, and check decimals. You could hone it in on an approximation, not very accurate. But, so yeah, they're not going to give you that because that's not a. What is this going to be? It's going to be either 1 or 6 or 36.
36.
Yeah, because you're doing
Yeah.
powers, exponents. So 6 to the 0, 6 to the 1, 6 squared, 6 cubed. I probably want to give you 6 cubed. Sometimes they give you ones like this, log, we'll call this number 3, log base 5 of 1 over 125. So that one's like, ooh, because it's a fraction, right? But 125 we recognize as a power of 5, right? What's 125 as a power of 5? 5 cubed, right? But the issue is that I'm asking 5 to the what gives me 1 over 125. So again, if you need to write that, that can be helpful. 5 to the what is equal to 1 over 125. Negative 3, yeah. So you'd have to recognize this is 5 cubed, and since it's reciprocated, x would be equal to negative 3, so my answer is negative 3. What's the matter?
The ground.
The ground's the matter?
Yeah. What's on the ground is the matter.
Okay, what's on the ground?
Fate's keys.
Oh, yeah, yes, that one's good. You'll come looking for him here shortly.
I can bring it shortly.
Well, he has next period here.
Oh, that's true. Just one too.
Yeah, that's right.
We're on the
Okay.
So we want
Make things more interesting.
It's spicy. Okay. So then you're gonna have a couple like this though. They say, given the ln of 5 is approximately 1.6094, okay, they want you to find the ln of 0.2. It's number the fourth example. So again, no calculator. So what they're wanting you to do is think through logarithms, think through bases, think through, okay. So if you can, we know ln is a base of e, right? So you're asking e to the what gives me 0.2. Well, without a calculator, you wouldn't be able to do that, except for the fact that they gave you ln of 5 is approximately, 1.6094. So ln of 0.2,
Would that be 1 over 1.6 or nothing? Because 0.2 is 1/5.
So really, you're saying ln of 1/5, right?
Yeah.
And then 1/5 is ln of 5 to the -1, right?
Mm-hmm.
And this is where, actually, on some of these over the years, I've thought through it, where and I don't know if we're supposed to appeal to the rules now, although because we learned them in Algebra 2, but 5-6 talks about the laws of logarithms. And I don't know if you remember this from Algebra 2, but do you remember what you can do with the exponent, the -1? Okay, let me just tell you now. You can bring it out front, and with logarithms, that's a rule, you can bring it out front. So it comes out front, you get negative ln of 5, and then what's the ln of 5?
1.6.
Yeah, 1.6094. So I'm not sure, there may be another way to get that, but that's a rule that we review in 5.6, 5-6, that you can bring the exponent out front. Okay, so I'm not sure if it's if there's something else they wanted us to do, but that would be fine to do. B, let's do another one, ln of 25. So now we can appeal to the same rule. What's the ln of 25?
Just be 1.6 times 1.6.
Yeah, so it's, well, not 1.6 times 1.6, but it's ln of 5 squared. What can I do with the 2? What's the
Bring
limit?
it out front.
Yeah, the exponent can come out front.
So then you
Yeah.
3.3 something.
3.2.
2, 1, 8.
188, maybe?
Something.
Yeah, I think so.
I feel good about it. Okay, then you're gonna have something though that they talk about, and that is, it's not like it's reviewed a lot or tested or anything, but it's interesting. Page 191, they talk about the decibel level. So on a decibel level, they have this little formula. Decibel level, we're referring to what when we talk about decibel levels? The sound, right? Sound something. So I don't know if you've ever tracked on like a sporting event, they show you like a decibel meter on the screen or on the TV, and you're trying to raise the level of noise, and it's like, I don't know, like 104, 105, So certain levels are bad for your ears and things like that. So the decibel level, they have this on, you're not gonna need to memorize this formula. They have a couple problems or a problem that I assigned, and this is kind of interesting that it relates to logarithms, and so you won't need to memorize the formula. If I put something on the test and just give you a little formula, it's pretty straightforward. But they talk about this where the I sub 0 represents the intensity of a sound barely audible. So I sub 0 would be a sound that's barely audible. Okay, and then I is just the intensity level of any other sound is measured in terms of I sub O. So I is the intensity level of that sound. So the decibel level comes by multiplying 10 times the logarithm of I over I sub 0. And decibel level is usually D, like something like D capital B. So then you go over to the next page, and on the next page they have a barely audible decibel level. Okay, I sub 0. So the decibel level, something that's barely audible, would be 0, right? And then as your decibel levels increase, you can see a decibel level of 10 is represented where I is a whisper would be 10 times I sub 0. and then leaves and a breeze would be 10 squared, I sub 0, the decimal level would be 20, so on and so forth. So you have a problem, they'll state with this, whatever, call this number 5. They're going to say find the decimal level for each sound with the given intensity I. So a softly played flute, okay, is the intensity level given to you as 10 to the 4.1 I sub 0. So that's just the intensity level of a flute being played. So all you do is, if you want to find out what the decibel level is, you'd have to know the flute, the sound intensity. But all you do is you plug that into your little formula, where I, right, for our decibel level. So decibel level of I, so we're going to say dB is equal to, because we want to find what is the decibel level of a flute, and the intensity, and say 10 log I is 10 to the 4.1 I sub 0 all over I sub 0. So then the I sub 0's cancel, right? And then decibel level would be 10 times the log of 10 to the 4.1. You can either bring that 10.41 out front, or you actually know what the log of 10 to the 10.41 is, because a base of 10, right? But you could also just bring it out front, and it would be 41 times the log of 10, and then what's the log of 10? 1. And so you just get 41 as the decibel level. So, don't want to go into the science behind it, the physics and stuff like that. But here's your little equation, and it's kind of cool. Talking about decibel level with logarithms. So, all right. So that makes sense there, maybe. Then just a couple more types of problems now. Again, these ones are going to stay without a calculator. Okay. That means you're going to leave your answers maybe in terms of E or base 10 stuff. So let's go like this. They're going to say leave answers in terms of E, solve for X. I don't know what we're on, 6 here. Okay. So you have ln x equals 2. So you're solving for X, but you want it in terms of E. So all they're going to do is base E. So E what? E squared is equal to X. So X is equal to E squared. Okay? Then you're going to have, okay, this is a good one. ln of absolute value of X is equal to, hey, Miss Smith.
Hello, how's it going?
Good.
I have a birthday card for your beautiful mother. I was hoping you would give it to her.
Oh, it is her birthday.
It is coming up.
It is. I will see her Sunday.
Thank you.
Thank you.
Yes.
Can I open it?
Yeah. No, but that's just for your mom.
Money? My money. Thank you.
Yeah.
Invest in the stock market.
We'll give all the profits to charity.
Okay, so then, okay, we were on absolute value of X is equal to 2. Very good. So now, just set up your equation. Absolute value of X is equal to what?
E squared.
E squared. Therefore, what can X equal? X is equal to plus or minus E squared, right? It can equal both there. Log of X squared equals 4. Let's do that one. Log of X. Okay.
Square root both sides.
There you go. So log of X is equal to
2.
plus or minus
2.
2. Now let's think about this. Can it be a negative 2? Yes. So let's set up two different things and think about what we'd be getting. Log of x is equal to 2, log of x is equal to negative 2. So what would this one be? Let's start with the positive. 10
Squared.
x equals 10 squared, right? X equals 100. Okay, that makes sense. I didn't state this, but the base on a logarithm can't be 0. I don't know if I didn't state that today, but and it can't be negative, so it's values greater than 1. I don't know if they specify what that is.
Wait, greater than 0 or greater than 1?
I mean greater than 0, but it can't equal 1 either. For logarithms. They do have that definition on page 193. The base has to be greater than 0 and it can't equal 1 on a logarithm.
Okay.
Now it could equal 1/2, can equal a fraction as a base is fine, but it can't equal 1 and it can't be negatives. Alright, so here though, we're not talking about the base, we're talking about x. So here you just say, okay, x is equal to 10 to the negative 2, so x is equal to 1 over 100. I think they put a decimal answer, but that's fine. Okay, so then, now it says use a calculator. Yes, finally. Let's do one more here. This is number 9. ln of x equals 1.73. Okay. So, in other words, they don't want the answer in terms of e. They want it in terms of a decimal, so you're just going to say x equals e to the 1.73, and then what does that give you on your calculator? Okay. Okay. So there you go. There's some other problems in there that hopefully make your life difficult. Always. They do talk about like some domains and ranges of some of the graphs or like an equation of logarithms, but we can hit that up later. What is due on Monday? 5, 3, and 5, 4. This is 5, 5. No, we won't make this due Monday. MC8 Tuesday. Have a good weekend.